Here I'm trying to explain you the resonance structure of heterocycles, 5-member heterocyclic rings. This X can be sulfur, nitrogen, oxygen, having lone pair. Now this is numbering system. Start from sulfur heteroatom 1, then 2, 3, 4, and 5. The lone pair of electron in the first in case of this resonance will be shared between this heteroatom will share its lone pair of electron, second carbon therefore forced to push the electron from its place to this pi bond. Electron will be shifted on third number carbon, so third number carbon will have negative charge. Lone pair of electron shared between first second, the pi bond shift on third carbon. Then this negatively charged here carbon will shift this electron, will share between this carbon, so electron sharing will take place between this third and fourth number carbon. Double bond will form, pi bond will form, and same thing happen here also. The pi bond electron will shift on this fifth carbon, negative charge will form here on fifth carbon. Then this negative charge will be shared between this fifth carbon and heteroatom. A pi bond will form. The electron will be shared in the form of pi bond, and therefore this electron will shift on second number carbon, and second number carbon will have negative charge. Then second number carbon will shift its electron will share electron with third number of carbon, will form a double bond, pi bond. Here, because these electrons are shifted, therefore this pi bond will shift on fourth number of carbon, negative charge here. Then this fourth number carbon and fifth number carbon electron will be shared, double bond, pi bond will form, and this bond, pi bond will shift on this heteroatom. Both the electron of this pi bond will shift on this heteroatom. A regeneration of that structure takes place. So it's simple. Heteroatom sharing its electron, lone pair of electron, and negative charge is developing and pi bonds are forming. So these are the resonance structure of any heteroatom, heterocycle. You can take sulfur, nitrogen, or oxygen heteroatom. In all the cases there is lone pair of electron, and same kind of the structure will take place. Now we will try to understand the model. Now this is a heterocycle. This is lone pair of electron of heteroatom. This is second carbon, third carbon, fourth and fifth. Here this is sigma bond. The lines are sigma bond. So this carbon having 3 sigma bonds, and this is pi bond, fourth valence is in the form of pi bond. So this way here is also pi bond. Now what is happening here, what we are seeing, this lone pair of electron will be shared between this first and second. So this lone pair of electron will be shared here. This is lone pair of electron on this heteroatom. It will share this electron with second number of carbon, and therefore this pi bond will shift on this third, fourth. And how it is shifting? It is first making this negative, third carbon negative. What we are seeing here, third carbon negative, so it is negative, and then it will shift on between this third and fourth carbon, making this fifth carbon negative. So this electron will shift here, and same thing happens here also. This fourth and fifth number carbon, this pi bond will first shift on this carbon, fifth number carbon negative, then between this fifth carbon and heteroatom. Now this will force this pi bond to shift on this second number of carbon. This electrons, because pi bond is forming here, will shift on this carbon fifth, and then it will shift between this fifth carbon and heteroatom. Therefore this pi bond will shift on this second carbon negative charge, which will shift between this second and third carbon. Therefore this pi bond will shift on this fourth and fifth carbon. Again here these electrons alone will comes toward this heteroatom as a lone pair. So regeneration of that structure, first structure, will take place.